Okay, our next speaker is actually going to be piped in virtually. And I'd like to introduce Gail Sullivan. She's an architectural professional, and she's a managing principal at Studio G Architects in Boston. And again, Gail will be talking about some initial thoughts and brief comments, and then asking some questions that I think will get our Q&A started. So with that, we're going to switch over to Gail. And thank you, Sharon and Gail.
Hi, thanks, Mike. So I am, as Mike said, the managing principal of Studio G Architects. We've been around for 30 years. I started the firm in order to address many issues, both social and environmental. We are committed to carbon neutral buildings by 2030, a short 6 years away. So we are driving to net zero and near net zero on a number of building types that I'm very interested in hearing more about the wastewater recovery for. Public schools, other public buildings, including 24-hour occupancy treatment facilities and multifamily housing. And it's great that I'm coming right after Liz, because I can say what Liz was just saying very much represents most of our public and nonprofit clients, a great concern about how to access these kind of high performance design strategies because they are not cost neutral to the capital budget. So I'm really thrilled that MassSave and the utility companies are present to hear this. So thanks, Mike, and everybody from DEP for bringing us together. And I want to note one of the things I learned this morning that I hadn't thought about this technology. I'd been thinking about the energy side of it, but the point about the reduction in water use is just as important, it seems to me. We don't focus on that as much in Massachusetts as in some parts of the country, but it is critical. So mostly I have questions. I have no experience with this technology, but I can bring the perspective of the people who are trying to figure out how do we incorporate these various technologies into the buildings and campuses that we're designing, and especially how do we think about it in the early decision making. So I think the first question is, and we have some ideas about this, but I'd love some more clarity. What are the project size benchmarks for us to think about? So, Aaron, you said, forget about the single family home right now. That's not in the technology. But we have, for instance, affordable housing projects as small as 20 or 30 units. Is that a possibility? Or do we need to be more like the 60 units in the example you showed? Multi-building campuses, when is it appropriate? And community scale, what's ideal for this as we think about this? We're working at all of those scales, and so I need to understand what works. And then the other thing is specific building typologies. You all mentioned some of them. Nobody mentioned public schools. In Massachusetts, we've got the Mass School Building Authority, which provides some state funding toward local district schools. And that's one of the things we work on. I'd love to see how we incorporate this technology into the public school design. So I'll pause there, see if anybody wants to answer those couple of questions.
Yes, from the technology providers, did anybody want to weigh in on that?
Yeah, I wish I had those questions like listed in front of me. They're really good.
Yeah, the first question, and Gail, you could go in.
Yeah, the size benchmark. So whether that's by units or occupants or gross square feet, just for different project types, what are the set of parameters, right, that would make it make sense, make cost-effective sense?
Aaron, before you answer, I was going to mention something, that a resource that we're going to provide later on, and then you can dive in. Is that okay?
Sure.
So Gail, one of the things, I'll let Aaron and others talk about that, but we do in our afternoon session, we'll be talking about some resources that we put together, a technology matrix from all three of these partners that have some details that are going to be available. We have them here in the packets, and that information will be available online. But just as there's a lot of moving pieces and a lot of information, but I just want to mention that, and I'm going to turn it over to Aaron and the other technology providers to answer that. Thank you, Gail. Aaron?
And what I would say, Gail, is for our tech, our smallest opportunity right now is in Boulder, Colorado. It's called 3200 Bluff, 37 apartments, and it's working great. So, and the bigger the better, as I said before. So I don't know about you guys as far as scale, but right now, and we're working to go smaller, but 50 apartments is kind of that magic number where you have the load profile and the wastewater profile that match 1-to-1. But again, we can, depending on particular buildings, we can go down. Like I said, 37. Yep.
So for us,
yeah, go ahead.
for us, we're basically in the same ballpark of about 40 units. Our limiting factor is the 30-inch pipe, right? So if you're building 40 apartments and you happen to have a 30-inch pipe on the road, on the street out in front of you, you're good.
Yeah. It's really about the upfront, the capital cost for installing. So if there's a sewer right by it, you know, we don't do single family houses, but if there's a sewer right there, in theory, you could do it. It's the ease of access of the resource, but also the ability, if it's got the right load profile, we can capture the waste effluent from the building itself and put the heat back in the building, including schools. We've started to look at schools up in Ontario.
And I'm wondering what your thoughts are, because public schools are, you know, something that's significant across the country. And certainly in Massachusetts, we have a lot of aging schools that are being replaced, some of them being upgraded. So when is this the right thing to be thinking about?
Major retrofit, I would say, or brand new buildings going in, because the cost is extremely high for retrofits. And the problem with schools that we found is it's very seasonal, right? So it's we've run into some Maryland, did this massive push to put geothermal under every soccer and football field across the state, but they found that because the schools are only being run really during one season or the other, the fields were being super saturated or sucked dry depending on where they put them in. So the seasonal, the usage side of things for schools, it makes it interesting, especially because anyway, I'll leave it at that. That's one of the hard parts for us, the seasonality.
But one of the drivers I'm seeing, like my kids' school, were not built for the current climate we have. So we're now having, you know, and I'll speak Celsius, but plus 30 degrees Celsius days. And there's a need for air conditioning. It's now a health and safety issue, an acute health and safety issue. So there's that driver as well. There's a need for that. You know, you could go small window or, you know, air conditioners, limited efficacy, but major retrofit for sure, new build. But sometimes there are other drivers as well that really. And when we've talked about the business case, I mean, we've talked a lot about the dollars and cents, but the resiliency, redundancy, the health impacts are also things that we're finding more and more are driving the decision to move to a system like this.
Yeah, and Ed, thank you for mentioning that schools have to go to cooling, because for a long time, of course, people didn't want to say that, right? Because they're seasonal. But the fact is they have a lot of 90-degree days in the school year. So switching a moment then, Aaron, in particular, you mentioned pairing your wastewater recovery with other things, like with geothermal. And I'm trying to get a picture for that as well. Like, when is that kind of pairing the right thing to do? From my point of view, trying to talk to a client, it's already hard to talk to them about ground source heat pump, because that's an expensive capital proposition. And then to have two different systems that are expensive. How do we rationalize that? When is that the right move? Do we think about PVs, because then they're powering your equipment? Might that help? Because our job here is to drive to net zero energy and net zero emissions, right? So I'm curious about the pairing and when we should be thinking that that's the right move.
It's a case-by-case basis. I know everyone hates to say that it depends, but really, anytime you're looking at a geothermal project of any nature, you should explore wastewater and, quite frankly, every renewable asset that you could potentially use to. It's a blended mix that's going to get us to that net zero goal you're talking about. But part of our offering is, because we're such a highly engineered solution, much like these gentlemen, we are involved from day one. So if you bring us the project data, we will help you work through it to determine if it makes the most sense. Again, if you have access to that sewer and we can reduce the bore fields, massive upfront cost savings for the project. So anytime you're looking geo, I selfishly think you should be considering, you know, wastewater as an adder, you know.
Mm-hmm. Well, and actually, listening to you all this morning, I was thinking we should be looking at the wastewater recovery before the geo, because the resource is already there, right? So I'm trying to get rules of thumb because this is the way we try to operate. The technical stuff is so hard for our clients to understand. So if we as architects can simplify all of this and help them get to some broad decisions, it's helpful. And then I have a last one, and this may seem odd in Massachusetts, but the fact is in much of Massachusetts, people are relying on septic systems. And none of you, everything that you talked about was more urban, but I can say I live in the city of Boston's limits, and I have a septic system at my house. But more to the point, all of Cape Cod just about is on septic. Much of Western Mass is on septic. So have you got any applications? Is it reasonable to think about when one has septic or some kind of alternative waste treatment?
We generally try to avoid septic systems, similar to the reason I mentioned before about the effluent. It's the bugs, it's the processes that could potentially get in the way of our transfer, both in and out of it. So unfortunately, echoing said before, we can't be everything to everyone. So those for a lot of reasons, for decarbonization and just urban planning, the more we can push people closer together into these more densely populated sections, because now improve transportation, all those other benefits as well. So yeah, the outliers are going to be tough until we're able to come up with those mini systems for the garage, much like you would a battery for a car.
Yeah. Great. Thank you all so much.
Could I interject something on that comment about using wastewater alongside with geothermal systems? You would have to be sure to save the money on the installation of the wells, which are very expensive. You have to be sure that you had enough sewage flowing at the time that the peak load was going to occur. Otherwise, you'll still need to spend as much money on the geothermal system. And the other question that I don't know the answer to, but was interesting, was you can get a very, very, very substantial IRA credit for putting it in a geothermal system if it's 100% geothermal. If you put a wastewater treatment system in, would that impact your IRA credit? Because if it did, it would really throw the economics off.
And the answer is no for our system, because we have a wastewater holding tank, which buffers against those low flow periods. So you don't have to worry about peak and off peak. It's like we do the analysis up front and say, okay, you've got this much access to sanitary. Well, then we should size your tank for this size of gallons to make sure that we can have, if the project demands 2 hours of operation during low flow periods, well, then you might need a tank of this size. It's only 1 hour, shrink that down. So, and then beyond that, because that tank is a thermal battery, we automatically apply. So there is no.
So that's not a barrier.
That is not a barrier, and I'm not an attorney, so clearly we're still waiting for them to
work for the IRS.
Well, the law rolls out, just like Local Law 97 in New York City. The law rolls out, but it's the rules and regulations. That's where the rubber meets the road. Right. That's where we're going to, and so we're all going to be, until people start literally filing taxes with a 30 or 40% tax increase for a $2 million project, and someone says, "Wait a second," that's when we're really going to find out. But from what we've been told, there's no barriers.
I think, just Gail, to your point, talking to your clients, I mean, the benefit of working with an energy provider is you let them decide the optimal mix, right? And if you want to throw in some solar PV, there's almost no incremental cost. We've looked at situations like that. So the agreement is we'll give you hot and cold water. We'll guarantee that by a contract, and you'll let us figure out if it's going to come from sewer, from storage, from geo, from PV, whatever. Right? So it's the ability just to simplify things and take on that operational risk.
Thank you. I'm sorry, go ahead.
Oh, we're going.
Yeah.
Of course, yeah. And I apologize, I didn't clarify this in my introductory comments. So though Jen and I are sitting next to each other, we actually work in slightly different parts of our respective businesses. She's working in energy efficiency and I'm working slightly outside of it, but in a complementary way. My team is looking at our network geothermal pilot that we're running in Massachusetts right now. And so one of the things, going back to Ed's presentation, is there was the system coming out of the water well, and then there was the heat pump right next to it. And there was a very short run of pipe that was right here. You could easily imagine that run of pipe being much longer, serving a community, serving a neighborhood, serving a district. And then you would be able to think about the way to integrate different energy resources. Yes. And I think one of the things that's important with this technology is to say, a lot of times we're thinking about what an individual building owner can do. We're thinking about what they can take on. We're thinking about the incentive that they'll receive. But as we heard from, again, the example that Ed was presenting around the hospital, they're buying heating and cooling from the system. So if we could propose something that would allow for customers to be buying heating and cooling, conditioned fluid, and then we could manage the integration of the different resources, much as we do on the electric side today, as we think about base load power versus variable resources that are used to manage the peak, that would then differentiate and separate the sort of the risk profile and the integration elements of different technologies like this, allowing us to take advantage of wastewater where it was available, but then also thinking about how do we use boreholes, how do we use process waste heat more directly, potentially in ways that would allow for customers to take advantage of all of it. So my hope is that we can continue to think about the ways that individual customers can go forward with this, the studies and the incentives that might come directly from MassSave, but also we as the utility and my team specifically are thinking about the ways that we might work in a parallel path such that we would be able to prepare the technology for customers or entities that wanted to go forward with it in a slightly different way as well.
Thank you, Owen. Next, and Gail, stay on board there because there's going to be some more questions.